Okay, hello guys. So I hear you guys have tests tomorrow, so I'm assuming most of you are going to be watching on YouTube. And that's okay. This lecture is mostly theoretical. There is a little assignment / project. Okay, cool. I see Azam's just joined. Welcome. So there is a little like assignment / project type thing, like an online exercise. It's more like a game, or not really a game, a sequence of games, challenges, something like that. On databases that I'll share on the WhatsApp group. And I want you guys to do that after today's lecture. So watch through the lecture and then do that little quiz that I post on the group. That's like your homework for the week, okay? And then next week, don't worry, we'll see a lot of the similar content again. Do watch through the lecture if you haven't attended it. And yeah, do that assignments, but we'll see more about databases because we're on to the final chapter. So yeah, pity that some of you are missing because of tests. I think it's better not to cancel because it means we'll have more time for revision at the end. So it's better not to postpone and stuff, even if attendance is bad on a specific day. I understand that if you're under pressure for your tests and stuff, it's okay, right? That's why we're recording the lectures. Okay, so anyway, for those of you who are here, let's get started. Cool, so we'll just jump in. I'll remember to add that you were here on the register, Zam. And I already marked Jatin Sachin just to under the assumption that he would be like a bit late. So that's cool. Okay, so databases. Let's get started. In your book, if for those of you who do follow along in the book, I know there's quite a few of you, this section starts on page 142. So this is chapter 6, the final chapter of the course. Relational databases. Very interesting, very important topic, one that you can definitely turn into quite a nice career as well if you learn a lot about databases and how to use them. So without further ado, as we start, so there's a lot of practical content to cover in databases. And so we will go back to like those more practical programming exercises in a bit, plus the little assignment that I'm going to share on the WhatsApp group afterwards. But when starting databases, we do have to start by defining some terminology because there's a lot of words that we'll be using when working with databases. And if you don't know what those words mean, you'll just be totally lost. Okay. So this is that first lecture on databases where we'll figure out what some of these words mean. So a database is an organized collection of interrelated data. Fairly obvious definition, right? Like obviously you wouldn't want an unorganized collection of data, so it would be organized. And obviously the data is going to be interrelated because why would you have unrelated data in one database? That wouldn't make sense. So fairly trivial definition of database. In general, we don't really work with that definition. Nowadays, whenever people say database, they probably mean relational database, which basically the relational part of relational database specifies how the data is organized. So a database is an organized collection of interrelated data. A relational database organizes that data according to specific things. There are 3 things that it organizes according to: entities, attributes, and relationships. And we'll talk about them in a bit, but you guys will already be pretty familiar with what those 3 words are describing. Once I show you the definitions, I don't think it'll be a problem. One other thing that we should just mention before we get into it, there are systems that we use to manage and create and store and backup and work with databases, and those we call database management systems. Sometimes you'll hear them referred to as relational database management systems because most database management systems work with relational databases. So we add the relational just to be to emphasize that fact. Okay, cool. So with those words out of the way, I think the best way to do this is probably to just jump in and design a database. So there are these 6 steps that your book proposes on page 144. You can see on page 144, doesn't look too pretty, so I created this diagram. You'll notice there's a lot of text on these slides. Usually I don't like having a lot of text on the slides, but these slides are designed so that you can study from them. Okay, so you can see we've got a whole diagram here of all of our steps on how to design a relational database. So yeah, the steps are fairly self-explanatory. So the first step is to create a mission statement, which is basically just identifying why you're creating a database. So basically they're saying, Before you create a database, you must know that you want to create a database and why you want to create it. So I mean, fairly trivial, right? These middle 4 steps: determine the data that needs to be stored, divide the data into tables and columns, choose the primary keys, and identify the relationships, can all be grouped into one process that we're going to learn about in a little bit, okay? And then this final step, normalizing the database, is quite an important concept that we'll cover in quite a bit of detail, okay? So cool. What we have here is entity relation modeling. So these middle 4 steps can all be done through what's called entity relation modeling. Essentially, how you do entity relation modeling is you create entity relationship diagrams. So you could create some pretty pictures, and those pictures sort of solve these middle 4 steps for you. They'll automatically handle those 4 steps for you. Well, not automatically. You have to create the diagram yourself, of course, but you'll see that it's quite an easy process to get these 4 middle steps done. So let's just jump into that and create some entity relationship diagrams for some databases that we're going to be working with. So you can see an example of a database on page 145, or sorry, an example of an entity relationship diagram on page 145. I've got my own one in the slides, so that way you'll have 2 different examples that you guys can study from. Okay, so how do entity relationship diagrams work? As I was explaining, relational databases organize their data according to entities, attributes, and relationships. And so those are the 3 things that will be reflected in our ERD diagrams. Okay, so entities, attributes, and relationships. So this is the super important one of the main parts of today's lecture. So do understand what these 3 things are referring to. So an entity, so I'll just define the word entity. An entity is a construct that represents a physical object or concept. So guys, when you hear that definition of entity, what do you think of? A construct that represents a concept. If I tell you that, what concepts have we learned about in this course that is very similar to this definition of entity? I'll give you some examples of what might be entities. Usually they are represented by nouns. So some examples of what might be an entity in a database would be like book, customer, publisher, order. Book, customer, publisher, order. What similar things? So these are representing, it's a construct that represents some concept or object, like it represents a book or a tree or a customer or a publisher or any of these sorts of things. So what concepts are you guys already familiar with that has a very similar purpose? Can any of you name one? Variables. It's broader than that, Sachin, I think. How would you represent, before today's lecture, before you learned about entities, if I said, I want to be able to represent a book inside code, how would I do it? What would I do? What would I create in order to represent like a book or a customer or a person or a tree? How would I represent such a thing? What other concept is quite similar to this? Anyone? You guys don't know. Constructors. What is a constructor inside, Saham? What is a constructor construct for? Zeros and ones. It is, yeah. But so what is So a constructor is a method, right? What is it inside? What is it constructing for? What is it constructing for? A class, exactly, a class of things. Okay, so for example, you might, yeah, exactly. Okay, 2 of you got it, that's good. So yeah, classes. And think about it, right? Book, you could create a book class, a customer class, a publisher class. There were 2 examples that I gave you that you guys have actually seen before, right? You've seen a person class before. That was the first class I showed you, was a person class. We've also discussed the possibility of like a tree class before, right? Trees would have a certain color of leaf, things like that. Okay, so an entity, what you guys know as a class, is basically what an entity is. Okay, guys. An attribute, yeah, so attributes are the properties that make up or define an entity. Now, again, so entity is basically a class. Attributes are the properties that make up or define an entity. So instead of reading entity, just read class. And then the properties that make up or define a class, you guys know exactly what those are, right? We've worked with properties before, right? Classes inside C#, they have properties, right? Like variables that you can set for each object of that class, right? For each instance of that class. So, you know, that you can create a person class. The person would have a number of properties, right? Like a hair color, a weight, a height. This is the same, except we call them attributes when we're working with databases. Okay. So entities are just like classes. Attributes are just like properties. Okay. Relationships, this is where things get different. This is something that we haven't seen before. Databases have the ability to define this relationship. Okay. And the relationship is just an association between entities. Okay. So usually you can describe them in a verb. So for example, if we have a publisher entity, a publisher publishes books, or a publisher releases books. A customer places orders, right? So places and publishers are the relationship between our two entities, right? So like a person owns cars, okay? So you can see that there's a relationship there. Okay, cool. So entities, basically classes, attributes, ellipses. Relationships are just associations between different entities, like a verb of how the two entities relate to each other. So inside our ERD diagrams, an entity is represented by rectangles, attributes are represented by ellipses, and relationships are represented by diamonds. And so, for example, we can create this simple ERD diagram here. Now, there's another one in your book that can also work. But here we have a simple ERD diagram. So guys, I do want just to make sure you're concentrating. Can someone type what the two entities in this ERD diagram are? What are the two entities that we have here? Yeah, cool. So Saham got one, and cool. Yeah, that's the other, book. Cool. So we've got publisher and book. Okay, publisher and book. Those are our two entities. You can see that each of our entities in this case have three attributes. Okay, so ID, name, city, ISBN, title, author. Cool, you guys got them both. Okay, yeah, awesome. Everyone got them. That's good. Okay, cool. So we've got publisher. It has three attributes: ID, name, and city. So each publisher has an ID, they have a name, and they have a city. And the book also has three attributes: an ISBN number, a title, and an author. Okay. The relationship between publisher and book is that publisher releases book. So hopefully you can understand what this is defining, right? Each book will have these three things defined about them. Each book will have a title. Each book will have an author. Each book will have an ISBN number. Each publisher will have an ID. Each publisher will have a name, and each publisher will have a city. Notice that ID and ISBN are underlined. Okay, we'll talk about that in a little bit. So, but notice that they are underlined for now. And we've got this word releases because a publisher will release or publish books. Okay. Now you see on the left here, there's a 1 next to the publisher and an N next to the book. Okay. What that represents the number of things that we have on each side of the relation. Okay. So for example, one publisher releases many books, if you understand. One publisher releases many books. So the 1 stands for that there's one publisher. Again, there can be more publishers in our database, but on each side of this relationship, we'll be thinking about one publisher and all of the books that that publisher publishes. Okay, so like one publisher can publish many books. So each of our publishers will be able to publish many books. So that's what the 1 and N represents. Okay. And once you've defined this ERD diagram, you've actually basically designed a database. It's not we'll see how it can be improved, but you've basically designed a database. So once you've got this ERD diagram, there are just 2 steps you have to follow in order to convert that ERD diagram into an actual relational database. Okay. The first step is that you take each of the entities and you create a table for them. Okay. So a database is literally just a bunch of tables, guys. Sorry, I'm just taking off my jacket. It's a bit boiling. And by table, I mean exactly what you guys are thinking about, like just with rows and columns. That's a table. Okay. So there's going to be a publisher table and a book table. And each attribute will become a column in one of our tables. And then we'll define the relationship in a simple way. It'll look better on the next slide when I actually show you some tables. Okay. So we've got this entity relationship diagram on the left, and I'm going to convert that into a database. Okay. So you can see we have our 2 entities, publisher and book. The book has 4 attributes now on this slide. It has 4 attributes. It has an ID, it has a title, it has an author, and it has a genre. Okay. Likewise, we've got a publisher. It has an ID, it has a name, it has a city. Okay. So this is how we'll turn this into a database. Okay. We'll start by creating a table for each entity. So I'm going to do the publisher first. You can see I've created a table here. The table has 3 columns, okay? 1 for each attribute. So you can see there was the ID that got this column, okay? There was name, okay, that got this column. And there was city, which got the final column, okay? So each of our attributes just became a column in our table. And you can see I just put some data into the table. So we have 3 publishers in our table, okay? 3 publishers: Project Gutenberg, Infogrid Pacific, and Penguin. Those are the 3 publishers that we have in our table. Okay, so that's fairly simple. That's how you'd expect to convert that left side, that the publisher entity, into a table. Hopefully you can agree. And now to create the final, to finish the database, we have to create a book table as well. So here's a table for books. You can see that the book ID got its column. Okay. Again, forgive my drawing. I'm just using my trackpad. The book title got 1 column as well. The book author got another column, and the book genre got another column. Okay, the final column. So we created that, but you can see that the book table actually has that 5th column, the publisher ID, the publisher ID. And all that does is it relates each of our books. So we've got 3 books and we've got 3 publishers. You can imagine having a lot more data than we have here. I just added these 3 books and these 3 publishers at random. So the 3 books we have are the War Poems of Sigrid Sassoon, the Metamorphosis, and Grimm's Fairy Tales. Okay, so actually, I think you guys would probably be able to read this already. So I want you to trust your instincts. And I'm going to ask you this. Which publisher published Metamorphosis? Okay. I haven't showed you much about databases, but I think you guys will already be able to read them just from this short little explanation. Which publisher published Metamorphosis? Nicely done, Saham. Yeah, exactly. So Saham's correct. It is Penguin. Okay. How do we know it's Penguin? Oh, sorry. Okay, cool. Sachin, you got a 2. That's cool. So how do we know it's Penguin? We can see, yeah, exactly, the 3. So I asked you which publisher published Metamorphosis. So you went and you found Metamorphosis. You saw that the publisher ID was 3. And you can relate that back to our publisher table. Our publisher ID over here is 3. And you can see that that is Penguin. Okay. I can ask you another question. Let's see if you can use. So remember, I asked you to take notes on the previous slide. That ID, this was ISBN on the previous slide. It's now just ID because IDs are easier to type, right? I could just type 1, 2, 3 instead of typing the full ISBN number of the book. So I just made the books have an ID as well. But I did tell you to take note that ID and ISBN were underlined. So you see that ID and ID are underlined. So the publisher ID and the book ID. That's because, so when we underline it, it means that that is what we call the primary key. The primary key. It is the column that uniquely identifies each row of our table. Okay, it uniquely identifies each row of our table. Now that might sound a little bit confusing, but you guys just used this idea already. Okay, you can see that when you found the number 3, 3 uniquely identified a publisher, right? The number 3 uniquely identified one of the publishers in our publisher table. So let me ask it to you this way. If you can answer this question, then you'll understand. What city does the publisher who published book number 1 come from? What city does the publisher who published book number 1 come from? Careful, careful, guys. Book number 1, not publisher 1, book number 1. Which city does the publisher who published book number 1 come from? Okay, be careful of how you're reading the table. So I'm asking you for book number 1, not publisher number 1. So it's not Springfield. Hey, okay. Sorry. I was just getting a mouse quickly so that I can draw better, because I think I'm going to be drawing a lot. So yeah, Sachin, you're correct. It is Singapore. So let's see how Sachin got to that, and we'll see now. Okay, hopefully I can draw a little bit better with this. It's not going to be much better, but it should be at least a little bit better. So I asked you for the publisher who published book number 1. So what some of you did at first was you went to this idea over here, right? And you were like, okay, that's number 1, which is Springfield. But remember, this is the idea of the publisher, okay? This was the idea of the publisher. So I asked you for what city does the publisher who published book number 1 come from? So you would go to book and you would go, okay, so I'm looking for book number 1. Okay, that's book number 1. Okay. It was published by publisher 2. Okay. It was published by publisher 2. Publisher 2 is over here, and their city is Singapore. Okay. So that's how we read that. All right. So yeah, you can see that each table, so our publisher table and our book table, has its own primary key called ID. Okay, so each publisher has their own ID and each book has their own ID. So, and you can see that each ID identifies a single row in the table uniquely. Okay, a single row in the table. So book 1 is the War Poems of Sigrid Sassoon. Book 2 is Metamorphosis. Book 3 is Grimm's Fairy Tales. Publisher 1 is Project Gutenberg, 2 Infogrids Pacific, 3 Penguin. They uniquely identify. Okay, you couldn't use the same ID for both because we only have 3 publishers here, so it works currently. But you can imagine that one publisher could publish more than one book. So books need their own ID and publishers need their own ID. They each need their own primary key. Okay, primary key. That's what we call that. It uniquely identifies each row. Okay, cool. So on to the next bit. You might think, so you can see we can use this database fairly well, right? You were able to answer some pretty interesting questions about our data. So for example, I could ask you, yeah, I mean, you guys have seen probably enough examples now, but I could say, what genre did Project Gutenberg publish? What genre was the book that Project Gutenberg published? Can you guys answer that question? What genre did Project Gutenberg publish? So now we're reading it a little bit backwards. So there was a book that exactly, Saham, yeah, 100%. It was fiction. So we can read it this way. You would say, all right, so you're looking for Project Gutenberg. So you find the one, you found Project Gutenberg. You were like, okay, its primary key is, its ID is 1. So then you went over to the book table. You found the books published by publisher 1. and you jumped and you checked out its genre, fiction. That's 100% correct. You're reading the database correctly. Okay. And you can see that this does kind of help you, right? This is called publisher ID. Publisher ID. So this is the ID of a publisher that we're specifying in that column. Okay, cool. But yeah, I trust that you guys can read it, and you can see you can answer some pretty complicated questions with this simple database, right? So job done, right? We understand chapter 6, we understand databases, but obviously it's not that simple, right? So yeah, it turns out that this database would actually be quite bad, guys. It would actually be quite bad. There are much better ways that we can construct this. Okay. So you can see what we've done now is these middle 4 steps, like I was saying earlier. The entity relationship diagram allowed us to handle these middle 4 steps, but we've still got this 5th step on the end here: normalize the database. And the description of that step says resolve issues that may affect data integrity. We will, okay, you can ignore the we will learn the rules later because we're actually going to be learning them right now. Okay, so resolve issues that may affect data integrity. Okay, so what do we mean by data integrity? Okay, so how do we normalize a database? We follow a process of normalization, and we do it to protect what we call data integrity and to improve what we call the ease of maintenance. So how easy it is to maintain the database and to fix it up, okay? To update it, to delete items, to add new items, all of that kind of stuff would fall under ease of maintenance. Okay, so data integrity can be challenged by 3 different things, okay? Each of those 3 things is what we call an anomaly, okay, a data anomaly. So let's look at our simple table here. I removed the publisher ID because we're just thinking about this one table now. We're going to focus in on this one table. Okay, so it looks fairly good. We've been able to do some interesting problems with this table, but why is it so bad? Why do we need to normalize it still? Well, there are quite a few reasons why this table wouldn't work. And yeah, so let's discuss those. So as I said, there are 3 different anomalies that you need to know. So the first anomaly, the first thing that can go wrong if you haven't normalized your database is what we call an insert anomaly, That happens when you can't insert new data into the database because there's some unrelated information. So I'll explain now. So for example, a good example here would be, what if I wanted to add another genre to our table? I want to add another genre. So for example, I want to say, okay, there's going to be a 3rd genre called history. Okay, I'll just type it out. A 3rd genre called history. Okay. I don't have any history books yet, but let's say, like, as a company, as a library, we're looking to go and get some history books. And so I just wanted to add history as a genre to our database. Okay. What problem do you guys foresee happening here? What problem do you guys see here? Would this work? Can I just add this genre, history? I just want to add another genre. What do you see that might be wrong? Yeah, okay, Saham. So why? Could you put it into words? You can picture, just add like another little row here. What's wrong with that? Yeah, exactly. Number 1, you need an ID. Okay. So you would need an ID, and this ID is supposed to uniquely identify a book. It's supposed to identify a book. So if I asked you now, like, what's the title of book 4? You wouldn't be able to say, right? Because I didn't have any history books. I just wanted to add the genre of history, right? I wanted to add the historical genre to the database, but I didn't have any history books yet. Okay, so that's what we call an insert anomaly. Because of how this table is designed, because it hasn't been normalized yet, sometimes when I want to insert data, like for example a genre, I can't add a genre to this table without adding a book of that genre. Okay, even though genre, technically the genre of history exists, it's not related to the specific historical books, right? Like without having a history book, I can know that the genre of history exists. Okay. And so you can see that's why they say due to an unrelated dependency. So you can see our table genre should be separate. It should be somewhere else. Like the books should be here and the genres should be somewhere else. And then we can relate them to each other. You shouldn't have unrelated things in the same table, or then it can cause insert anomalies. But yeah, so an insert anomaly is the one. But I said there were two others. So another one is a delete anomaly, a delete anomaly. So this occurs when you delete one piece of data, and because your database is designed poorly, it deletes some unrelated data as well. Okay. So for example, if we look again at our simple book table over here, let's say one day, so we're going to go over 2 work days. You're a database administrator at some big corporation, and you're asked, hey, we no longer list the war poems of Sigrid Sassoon on our database. This book is gone. We had an argument with the publisher. We're no longer able to list the war poems of Sigrid Sassoon on our database. Could you please delete it? So you go ahead and you delete the war poems of Sigrid Sassoon. Okay, you delete it. The following day, you come to work and they ask you, okay, look, so we're preparing a presentation and we would like you to get us all of the genres that we have ever had on our site. So go and get all of the genres that we've ever had on our site. Or they could come and ask you, hey, could you go and get all of the authors that we have ever listed on our website? So all of the authors that we have ever partnered with. Do you see how we've now caused a problem here, guys? Do you see how this has caused a problem? So if they came the following day and they asked you that, they came and they said, hey, what genres have we listed on our site over the history of our library? You would now not be able to know that poetry was once on the site. Okay. You've forgotten that the genre of poetry existed. You've also forgotten that Sigrid Sassoon was an author that existed on your site. You've deleted the author and the genre along with the book, along with the title. Okay, so that's called the deletion anomaly, where deleting one piece of data causes you to lose unrelated data. So that can also happen if you haven't normalized your database. Okay. The last kind of anomaly that can occur if you haven't normalized your database is called an update anomaly. An update anomaly. Oh, sorry, I shouted there. Okay. When updating a single data value requires you to update multiple rows. So we can see this quite easily in our database. Let's say one day we decided that actually calling metamorphosis fiction is not really specific enough. We actually want to say that this is literary fiction. Literary fiction. But the issue is, if you update fiction to literary fiction, you have to now go and find every single entry of the second genre type, and you would have to update that to literary fiction as well, right? You would have to update both of these to literary fiction, which is a huge process, right? You can imagine in a database with 100,000 books, if you just want to update a single genre's name, you shouldn't have to update every single row in your database. It should just work. You should just change it in one place, and the database should know to look there if it's wondering what the genre is. Okay, so that's called an update anomaly. When attempting to update one piece of data, you end up having to update multiple rows. So we wanted to update fiction, but fiction also occurred here, so we had to update this as well. Okay, so those are the kinds of things that can occur when you don't normalize your database. Okay, cool. So those are the anomalies. How do we fix them? We normalize the database, and normalization is just a process. It's a sequence of 3 steps or 3 rules that you have to apply. So you think about the rule, you see whether your database is following the rule. If it is, you're good. If it's not, you need to change something. Okay. So we're going to discuss those now. That process of normalization we'll go through now. But I think we can take a little break first. Shall we start discussing normalization at 10 to 4? Okay, guys, so like an 8-minute break. I think we've been pretty laid back today, so we don't have to do a full 10 minutes. Cool. Okay, guys, I'll be back now. I see that there were some people who's saying they would still join. I see Joshua's here now too. Joshua, do re-watch the parts of the lecture that you've missed though, like after I upload them to YouTube, please. Just in case. Cool. But I'll be back right now, guys. See you in a bit. Yeah, do catch up what you missed after I upload the stuff to YouTube, guys. Okay, cool. Let's move on. So yeah, as I was saying, so you guys will see one example of normalization here. There are other examples of normalization in your book as well. And also when I share that little assessment project homework thing for you guys, it's quite fun and it shouldn't take you guys too long, but please do it before next week's lecture. You'll see even more examples of normalization in that. So you will see this a lot, but do concentrate because the faster you get it down, the easier it will be to pick it up later as well and to just understand it later as well. So yeah, there's just 3 steps to normalization, and we call each of them a normal form. So there is a first normal form, a second normal form, and a third normal form. And after each step, your database will become better and better and better at resisting those anomalies that we discussed. So the insert anomaly, the delete anomaly, and the update anomaly. So we're going to start with first normal form. So each one is just a rule. And you basically just look at your database and you find out, does my database validate this rule? So for first normal form, it says, for a table to be in 1NF, none of its columns should contain multiple values. They say columns here. What they mean by the rule, so I'm taking the rule exactly from your book. That's how they write it in your textbook. But what they mean by columns, don't confuse yourself. They mean a cell, okay, a field. So none of the fields in your database, like none of the cells, okay, should have multiple values. Okay, so none of this, they just say columns because it means the same as attributes, okay? But let's look at our database over here, and you guys tell me. So look at each thing. So again, I'll remind you one more time. They mean like none of these. So like none of the cells. So for example, this cell over here does not contain multiple values. You can see it just says poetry, okay? That's not multiple values. You can see that this cell over here just contains the war poems of Sigfrid Sassoon. That's not multiple values, okay? You can see it doesn't contain like a list or a group of values. It's just one title. It's one book title, right? This cell over here, it just contains a 1. That's not multiple values. It's one value, okay? So can you guys tell me, is this table in 1NF? Is it in first normal form? For a table to be in 1NF, none of its columns, read cells, should contain multiple values. Can you guys tell me? Is this in T-E-S. What does that mean? You're saying yes. You guys are saying yes. Huh. Okay, I'll tell you that it's not. This table is not N1NF. It is not N1NF. Okay. So look for a cell that you think, so I've given you some examples now, right? I've showed you 3 cells that didn't contain multiple values. Can you guys find one that does? Hey, okay, cool. So Saham was quick on the draw. Yeah, exactly. It's this one over here. Okay. You guys see it says Jacob Grimm, comma, Wilhelm Grimm. Okay. So guys, I'll give you guys a little trick. You can apply this rule very easily by looking through the table for commas. Okay. If there's a comma somewhere, that means that that cell definitely holds multiple values. Okay. Or almost definitely. Okay, so for example, that you can see the example in your book of 1NF. I think it is on page 148, if I'm not mistaken. Let me just double check for you guys though. Again, no, 147. On page 147, they have a column called phone number, and two of the cells in the phone number column have multiple phone numbers. So they have a person's phone number, comma, and then like a second phone number for that person. That's multiple values. Okay. So the first rule is just none of your cells, or again, you can read columns, must contain multiple values. Okay. So you see this column, the author column, does contain multiple values in a single cell. Okay, so that violates the first normal form. And so we have to fix that. So how do we fix it? And you guys will see there's a common way to fix most of these problems. It's usually to split the table up into 2 tables. So how would we fix this? We would remove author from the book table. We would remove author from the book table. And we would put it in another table. Okay. Obviously, we would have to normalize that table as well, and we would have to recheck. We would always have to like double check. But you can see that we've split it into another table. And now we have 2 tables. One of them will discuss the details about authors, and the other one discusses the details about books. And now you can see that none of our tables, none of our columns contain multiple values anymore, because you can see that author ID 3 and 4. Okay. So those 2 there. They both have, so author 3 and author 4 both have book ID 3. Okay. And you could see that then points to ID of book 3. So over here, and that's Grimm's Fairy Tales. So now instead of storing both authors as like, as Wilhelm Grimm, Jacob Grimm, we now have them in separate rows in this other book author table. Okay. And so now we're in first normal form. Okay. You can imagine this is a little bit, I don't have to tell you guys this, but you'll notice it on the examples in your book as well. Here, we're assuming that one author can only write one book, because you can imagine if Wilhelm Grimm wrote another book, then we would have to repeat his name again, and we would then have to split that up again. Okay, but for this example where we have one author to one book, this works perfectly, and we are in first normal form. Okay, so we're in first normal form over here. And you don't have to think about what I just mentioned. You can focus on the fact that you can see that none of the columns contain multiple values. None of the columns contain multiple values. And remember, guys, if you're ever worried about having to normalize a database, like you're ever like stressing about it, just apply the rule. You just have to think about the rule. Okay. Each rule is really quite simple. Each of the rules is quite simple. And you just have to apply the rule to the table and just think, like, is it valid? Okay. Is the rule describing your table? Okay. You can see that none of our columns contain multiple values. So this table is in 1NF, and we can move on. Okay. Now, so 1NF was quite easy to understand, right? None of the columns must contain multiple values, and you can read fields. Okay. So that's fairly easy to understand. 2NF will be slightly more difficult because we have to learn about two other concepts before we learn about 2NF. Okay. So the first concept that we have to learn about is something called functional dependence. Functional dependence is a very important concept in databases. And if you understand functional dependence, you really will understand a lot about databases. Okay, so concentrate. The definition of functional dependence, they don't provide one in your book, but this one can get you out of a jab if you're worried, if you're forgetting. So Y being functionally dependent on X means that the value of X uniquely determines the value of Y. Okay, that's the definition of functional dependence. The other way to think about it is just with a little graphic. So you can picture it as just like this. We have a column X, okay, or a field X, and X must imply Y. Okay. If this is true, then we know that Y is functionally dependent on X. Okay, so I'll show you this with our example, and then I'm sure you guys will understand. Okay, so X must uniquely determine the value of Y. So what we mean by that, okay, we can look at an example here. So ID and title. So ID is the primary key. You can see ID is the primary key. And guys, by definition, every single column in your database is going to be functionally dependent on the primary key, because the primary key will uniquely determine the value of any other column. So let's take, we're going to take a simple example. Okay. So if I tell you one, you know that the title is The War Poems of Sigfrid Sassoon. Okay. If I tell you I'm talking about book 1, you know that the title is The War Poems of Sigfrid Sassoon. You also know that the genre ID is 1. Okay. There's no gray area. The ID over here uniquely determines what the genre ID is. Okay. You can also see the ID of 1 uniquely determines that the genre is poetry. Okay. But you can see that this would not always be the case. So you can see that currently we have that title, genre ID, and genre are all functionally dependent on ID, right? So all of them are functionally dependent on ID. If you know that the book ID is 2, you know what the title is, you know what the genre ID is, and you know what the genre is. If you know that the ID is 3, then you know everything else about the book. Okay. But you can see that in the reverse, this is not the case. Okay. So for example, let me ask you this. Can you guys tell me what is the ID of the book if the genre is fiction? What is the ID of the book if the genre is fiction? You can't answer the question, right? It's not possible because here the genre is fiction and the ID is 2, okay? But here the genre is fiction and the ID is 3. So how can we answer this question? We can't, exactly. You can't. So what we can say is that ID is not functionally dependent on genre. So I'm just going to write G for short instead of genre. We can say that ID is not, so I'm crossing it out. ID is not functionally dependent on genre, but genre is functionally dependent on ID. Okay. So you guys can see the relationship. Okay. It uniquely determines it. You can imagine we could have some other data in our table. Here, all of the titles are unique as well, right? Like technically, we could use our title as the primary key, right? Because if you know that the title is The War Poems of Sigfrid Sassoon, you know everything else about the book because no other book has that title. But you guys can imagine that there could be books with the same title, and so then that would be fine. All right. Okay, cool. So that's functional dependence, guys. If you know the value of this column, so if you're wondering, like essentially, is a column functionally dependent on ID? If you're wondering that question, for example, then you could say, okay, if I know the value of ID, do I know the value of that other column? If the answer is yes, in every case, then the other column will be functionally dependent on ID. Because in this case, ID is the primary key, it will always be the case, okay? Everything will be functionally dependent on ID because it's the primary key. But I showed you an example where two columns were not functionally dependent, right? Like title is not functionally dependent on genre, because if you know that the genre is fiction, you don't know the title, right? You know the genre is fiction. That means the title is either Metamorphosis or Grimm's Fairy Tales. You don't know for sure. So the genre is not uniquely determining the title. But you can see that the ID is uniquely determining the title. Okay, so that's functional dependence. I hope you get it. You will see more examples of it as you go through the little assessments, and also in next week's lecture as well. We'll see a little bit more of it. Important idea to grasp, though. The other idea, and this one's easy, you don't really have to think about it too much, is that some tables have more than one column in their primary key. So you saw in our last example, the primary key of the book table is ID, right? The primary key of the author table was author ID. So you see it only has one, it still only had one column underlined. You see, it's just author ID. One column is the primary key. You can see on the previous tab as well, publisher ID or publisher, the publisher table was uniquely identified by the ID of the publisher. So it only had one column in its primary key. So all the tables we've seen so far have had an ID. So they had one column in their primary key. But not all tables are like that, okay? They should be like that, but like you should design your database so that all tables have one column in their primary key. But there are cases where that's not the case, okay? So I've just given you a simple example here. You can see that there are two columns that are underlined, okay? So each row in this table is uniquely identified by two numbers, okay? So like if you know just one, like if you know only the animal ID, okay? If you only know the animal ID, you don't know which row you're looking at. If you know that the animal ID is 1, you don't know which row you're looking at. You can see that, right? Because you don't know if you're on row 1 or row 3. Now, in this example, and you can see it's like this in your book as well, that's why I'm exposing it to you, it doesn't need to be the case that both of these are in the primary key. It's just defined that way for this table, okay? Because you can imagine if we just made ID the primary key, you would be able to uniquely identify each row, okay? But they didn't define it that way. So we call this a composite key because it's made up of multiple parts, all right? And the English word composite, it means the same thing, okay? It means it's made up of multiple little components. It's a composite, okay? So yeah, so we have here we have a composite key, and that's just what it means. There's more than one item in your primary key. So 1, 1 means you're on the first row, 2, 2 means you're on the second row, 3, 1 means you're on the third row. Okay, so you need the two numbers to identify each row in this table. Okay, didn't have to be that way. It's just defined that way. Okay, cool. So once you understand the idea of a composite key as just being when there's more than one thing in your primary key and functional dependence, you can now think about the second normal form, okay, 2NF. Cool. So let's read the rule for 2NF and then we'll see what's up. Okay. For a table to be in 2NF, it must be in 1NF and all non-key columns, so that is any column that is not in your primary key, must be functionally dependent on the entire primary key. Okay. There is a second way of understanding this rule, so I'm just going to tell you about it before I show you the example. Okay. So the other way to think about it is that all 1NF tables with a single column as their key. So all 1NF tables, if they only have one column underlined, if each row is uniquely identified by one number and the table is in 1NF, then it's automatically in 2NF. Okay. So if I asked you, is this table in 2NF? You could just say yes. Okay. This table is in 2NF because we just saw none of the columns contain multiple values. So let's go through the rule. Let's go through the rule at the top here. So for a table to be in 2NF, it must be in 1NF. So none of the columns must contain multiple values. And you can see none of our columns here contain multiple values. This table is in 1NF. We just made it into 1NF. Okay, so that's the first part of the rule. The next part of the rule, all non-key columns, so every column that's not underlined, so every column that's not in the primary key, so that's not ID, so title, genre, ID, and genre are the non-key columns, must be functionally dependent on the entire primary key, the entire primary key. So you can see our entire primary key is just this one column. And by definition, every other column will be functionally dependent on it. Okay. So if you only have one column in your primary key and you're in 1NF, then you're automatically in 2NF. Okay. So cool. This table is in 2NF. This one. So let's consider our other example here. So for a table to be in 2NF, it must be in 1NF. Okay. This table is in 1NF, right? You can see none of its columns contain multiple values, right? You guys see that? So that's the first part of the rule. It's in 1NF. The next part of the rule. All non-key columns, so non-key columns are the ones that aren't underlined. So we're thinking about date and animal name. All non-key columns must be functionally dependent on the entire primary key. The entire primary key. Okay, so that is to say, all non-key columns must be functionally dependent on the entire primary key. So we can see that animal name is functionally dependent on animal ID, right? You can see that, right? Because you can see if I know that the animal ID is 1, then I know that the animal is rhino, right? You can see whenever the animal ID is 1, it means that we saw a rhino. Okay, so that's cool. It's also functionally dependent on ID. So 1, 2, 3, that's cool. So let's think about the other option. Okay, so date. Date is also a non-key column. Is it functionally dependent on the entire primary key? Can you guys tell me? Is date functionally dependent? It's not, right? If you know that the animal ID is 1, you don't know whether the date was the 28th of September or the 5th of October. You don't know, right? Because both of these have an animal ID of 1. So date is functionally dependent on ID, which is part of the primary key, but it is not functionally dependent on animal ID, which means it is not functionally dependent. Notice the word, guys. It is not functionally dependent on the entire primary key. Okay, so cool. That's how they discuss it in your book. I'm going to tell you a trick way that you can think of it, okay? That's even easier. For a table to be in 2NF, it must be in 1NF, and you can use either this rule, which is the rule they give you in your book, and it works, okay? So you can use that rule. The rule that you'll be shown in the assignment that I'll send you after this is the same. It means the same thing. So the rule that they will tell you there, or it means a similar thing. The rule that they will tell you there is for a table to be in 2NF, it must be in 1NF, and it must only have one column in its primary key. So if you just remove animal ID, then this table is in 2NF. So that's how easy it would be to turn this table into 2NF. Just delete this column. Okay. The other way you could do it is to just remove animal name from the table and make it so that animal ID is no longer in the primary key. You could also leave animal name in, but you just must make it that animal ID is not in the primary key, so that we only have one column in our primary key, and then we know if we only have one column in our primary key and we're in 1NF, we'll always be in 2NF, okay? Because every single column will be functionally dependent on our primary key. And since our primary key is only one column, that means it's functionally dependent on the entire primary key. Okay, so that's 2NF. It might seem a little bit complicated, and I think this is actually the most difficult one because you have to understand composite key and functional dependence. But remember the obvious rule. If there's only one column in your primary key, then you know it's in 2NF if it is in 1NF. So notice all the rules are like this. Each level will always imply the previous level. So for a table to be in 2NF, it must be in 1NF. And you'll see now, for a table to be in 3NF, it must be in 2NF, which means that it must be in 1NF. Okay, so they always, the next level always implies the previous level. Okay, cool. So that's the second normal form. On to the last one. So the last rule that we need to learn. Okay, so this is the last rule. For a table to be in 3NF, it must be in 2NF. Okay, so that means it must be in 1NF, so it mustn't contain multiple values in any of its columns. And it must be in 2NF, so that means that, okay, it mustn't contain any multiple values in any of its columns, and it must only have one column in its primary key, okay? Or there must be no functional dependent, or, you know, okay, so it must be in 2NF. There must be no functional, so that's the first part of the rule. It must be in 2NF. The next part, there must be no functional dependence between non-key attributes. There must be no functional dependence between non-key attributes. Okay, we're going to have to use our imagination a little bit here. Imagine that we have more books, okay? Like some of our books might have the same title. Okay, that's what you have to imagine here. Okay, some of our books have the same title. So just bear with me on that one. But you won't have to think about that initially. I think you guys will be able to spot it quite easily, hopefully. So guys, non-key attributes. So ID is our key. That should be underlined, guys. Sorry about that. ID is our primary key. They aren't always underlined, though. That was me being nice. You can kind of obviously guess that ID is the primary key of this table. Okay, they don't always have to be underlined. Okay. So ID is the primary key of this table. So we're looking at these three columns over here: title, genre ID, and genre. Okay, and you're being asked the question: is there functional dependence between non-key attributes? So can you tell me, is this table in 3NF? And if it is not, where's the problem? Okay, it's not. Yeah, it's not. So that means that there must be functional dependence between non-key attributes. Between non-key attributes. So where's the obvious functional dependence here? Exactly, Saham. Nicely done. That's very good. Okay. So Saham, can you predict how we might solve this actually? Or can anyone predict? So genre ID, you guys are right. Genre So genre is, yeah, you can see that there's functional dependence. Genre is functionally dependent on genre ID. So delete genre ID. Okay, yeah, that's not, those aren't bad suggestions, definitely, not bad suggestions. There is a better way of doing it, maybe. So I'm going to show you that way. You guys are right. That would work. In fact, that would work. Let me think. Yeah, that would work. So that would be one way of approaching it. There's a less drastic way of approaching it, of doing this. Okay. Now there is no functional dependence between non-key attributes. Technically, you can tell me that because each title is unique, this is why I told you, use your imagination. Pretend that we have another book called Metamorphosis. Okay, I'm sure there's at least 2 books in the world called Metamorphosis. So pretend we have another book called Metamorphosis, just for the sake of example. Because technically, title can determine genre ID, right? Because title is unique. It could even be our primary key. But you can imagine a situation where that wouldn't be the case. You wouldn't design your database assuming that title would always be unique. That's just because we have this specific data here. Okay. So you do have to use your intuition a little bit and like extrapolate what data you would be storing. You would never make your title like a primary key or anything like that. Okay, cool. Or assume that it would be unique. So cool. Yeah, we have ID, title, genre ID, and you can see that now genre points over to the secondary table over here. Okay. And you can see that this solves a lot of problems. Remember our update anomaly from the first thing. If I wanted to update fiction to literary fiction, I had to update 2 rows. But now I can just update this one. I can just update 1 row. If I update that fiction to literary fiction, then both Metamorphosis and Grimm's Fairy Tales would be listed as literary fiction. So you can see that solves our update anomaly. It also solves our deletion anomaly, right? Our deletion anomaly is also solved. If I go ahead now and I delete the war poems of Siegfried Sassoon, you can see that I still have poetry listed as a genre. I still have poetry listed as a genre in my genre table, even though I deleted the war poems of Siegfried Sassoon. You can see also, yeah, so all of our problems are solved now. Okay, all of our anomalies are solved. All right, and that's normalization, guys. That's 3NF. Okay. So what I'll do, I see we finished a little bit early. That's good. I think it's because we didn't do the Mentimeter quiz. And I did calculate the time as if we would have done the Mentimeter quiz. But that's okay. We'll do the Mentimeter quiz next week. And remember I said, so there is a assignment project type thing. You guys will see it's fairly self-explanatory. It's like a nice exercise. So I'll send that on the WhatsApp group. Please do that before next week's lecture. If you missed the beginning of this week's lecture, then please do watch it, okay, so that you know everything that we covered. And yeah, do the assessment before next week. I also said that I would post the solutions for the knowledge assessments, and I'll do so. I just need to type them up. So I'll do that on the WhatsApp group as well. Probably that I'll do maybe Friday. Okay. Cool, guys. So that's that for the lecture. Thank you. Yeah, we did end like 10 minutes early, but that's okay. Just means that you guys picked it up a little bit faster than I expected. Cool, Sachin, cheers. Yeah, thank you for coming. Cheers, Azam, thank you. Cheers, Judson, thanks. Cheers, Joshua, and cheers, Saham. Bye-bye, everyone, bye-bye. And yeah, see you guys next week. And bye-bye, Arjun, bye-bye. Thank you for coming. Yeah, and see you guys next week.